Okay, question 5. Got an electric water pump. It's powered by a 230 volt main supply. Here's the plug, so we can see the cable grip, the fuse, earth wire, live wire which goes into the fuse, neutral wire. This would be at 0 volts, this would be 230 volts. So, one wire in the plug is the earth wire, the other 2 wires are the live and the neutral. So, B. Describe the purpose of the component labelled X. So this is the fuse, and we know it's a thin piece of wire that melts if the current's too high. So we've got a thin piece of wire that melts if the current's too high. And we could add in there, this prevents a fault electrocuting the owner or a fire taking place. But I think the mark scheme is just, it's something that melts if the current gets too high. But that's a better answer. Go on to the next part. 230 volt mains, we're happy that's in volts. 9,000 joules, perfect. 1 minute, not happy with that, so times that by 60 is 60 seconds. And it says calculate the current, and we don't have to do anything, it tells us what to do. So the crucial bit is you've got to change that. So now we can plug it all in. 9,000 joules, that's the energy. Divide by the voltage, 230, tick, and then multiply by the time, making sure you've changed 1 minute to 60. And that comes to 0.65 amps. Okay, next question, we've got a Sankey diagram. The system transfers 8,400. Well, we can just see, I'm going to go in here, 9,000 in. I already know that's going to be 600 joules. This is useful. That'll be wasted and probably as thermal energy. And now we go into the questions. Explain why the useful energy is different to the total supplied. So some is wasted because of thermal energy being dissipated into the air. And, you know, how many times has that come up? So thermal energy is produced, which is dissipated into the air. It comes up all the time. Next one, calculate the efficiency of the pump. Efficient, useful, tools. And it's the useful, which is this, 8,400 divided by the total, 9,000. Doesn't want it a percentage, so we can leave it as a ratio. There we go, 90.93 or 93%. Done. That's a nice question.